Hello, welcome once again. Now I am going to discuss about the applications of HSAB concept or Pearson's HSAB concept. Friends, we know that every concept has its applications. If we see Arrhenius' concept of acid and bases, based on his concept, we can predict hydrogen donors are acids and hydroxyl ion donors they are bases. So which ions are donated by that particular species, based on that we can confirm whether it is acidic or basic. On the base of Bronsted-Lowry theory, proton donors are acids and proton acceptors are base. And according to Lewis theory, electron pair donors are known as bases and electron pair acceptors are known as acids. So in this way, every concept has its applications. We can know whether that chemical species is acidic or basic based on these concepts: Arrhenius concept, Lowry Bronsted concept, or Lewis concept. Similar to these concepts, Pearson's HSAB concept is also useful for many things. For example, if formed product will be stable or not stable, that can be predicted with the help of this HSAB concept. Also, it is possible to study relative strength of acids. With these applications, this theory has, or this concept has, some limitations also, that we will see later on. So first we have to see about the applications of HSAB concept. For this I have written these four chemical compounds or acids. HF means hydroiodic acid, HCl means hydrochloric acid, HBr means hydrobromic acid, and HI means hydroiodic acid. Among all these four acids, all these are acids, which is whose strength is more, which is more reactive, that we can confirm with the help of this HSAB concept. If we see the molecules of all these acids, one thing is common here. HF means hydrogen is a hard acid. In case of HCl, hydrogen is a hard acid. In case of HBr also, hydrogen is hard acid. And in case of HI, here also hydrogen is present as a hard acid. But bases are different. Here chloride ion is base, which is hard base. And here iodide ion is present, which is a soft base. So for the formation of HF, there is hard acid combination with hard base, and here hard acid is combined with soft base. So hard plus hard, and here hard plus soft combination is there. So based on this, we can say this HF is the stablest one. It is the most stable, but HI is least stable, because here hard plus hard combination is there, which results into stable compound. Here hard plus soft combination is there, because of that there is no more stability. Comparatively it is less stable than this HF. So here, if HI is least stable, it undergoes ionization very easily, and H plus and I minus ions it releases easily. Once these ions are released in the solution, these ions can undergo reaction very fast, and therefore this HI is very reactive, and that's why strength of this HI is highest compared to HF. It has highest strength of acid, right? Relative strength here we have seen. So comparatively HI has more strength than this HEF, that is hydrochloric acid. One more example we can see here regarding stability of product. Here hexacyano-cadmium is a stable complex compound. Why it is called as complex compound? Here cadmium metal is present, and cyano group, they are present as ligand units. So metal has been combined with ligands, that's why it is a metal complex compound. Here also cadmium is a metal part. To this cadmium 6 ammonia ligands are bonded. So this is also metal plus ligand combination, it is also a complex compound. Both are these complex compounds, but among these two, hexacyano-cadmium is more stable than this hexaamine cadmium. Why it has more stability? Hexacyano-cadmium is more stable because here cadmium is a soft acid and cyano is also a soft base. So soft acid has been combined with soft base, therefore it is a stable. And here cadmium is a soft acid and ammonia is a hard base. So soft acid has been combined with hard base, therefore it has comparatively lower stability. So in this way we can determine relative strength of acids, or we can find out which will be the more stable molecule based on this HSAB concept, because as per this concept hard acid prefers to combine with hard base and soft acid prefers to combine with soft base. So based on this fact we can predict relative strength as well as stability. One more reaction I have shown here. Here CH3F, so fluoride is a base, and here hydride ion is also a base. So this is a soft base. Now here 3 hydrogens are there. This hydrogen, that means CHF3, from this molecule one more hydrogen can easily shift toward this CH3 and it converts into CH4. So these soft ligands already they are present in this first molecule, therefore one more soft ligand easily comes to this molecule and here CH4 and CF4, that means tetrafluoromethane is formed. So this expression is possible with the help of this HSAB concept. Already I have told you that every concept, every theory has some limitations, it has some drawbacks or weaknesses. Similar to that, HSAB concept has some limitations. What are these limitations? This concept has no quantitative scale of measurement. So one molecule is stronger than another. By how much amount we can't predict. So there is no quantitative scale of measurement. How much amount we can't predict. So this is one limitation of this HSAB concept. This concept has no explanation about inherent acid base strength. Suppose particular species has more strength and particular species has less strength. Why it is inherent? Why it is more active and why it is not active? It cannot be predicted with the help of this HSAB concept. For example, hydroxyl ion is a base. It is a hard base. Similarly, fluoride ion, F minus ion, that is also hard base. But compared to OH and fluoride, hydroxyl ion is 10 raised to 13 times stronger than fluoride ions. So this strength cannot be determined or cannot be predicted with the help of this HSAB concept. So it is called as inherent acid base strength, cannot be predicted with the help of HSAB concept. Again, HSAB concept suggests that hard acid combined with hard base, but there are some exceptions. For example, SO4 minus minus when react with this stable molecule, this stable compound, hydrofluoric acid. Actually, hydrogen is hard acid, fluorine is a hard base. So hard plus hard combination is there. This is stable compound. But this fluoride is replaced by this SO4 minus minus ion, and here HSO4 is formed and this fluoride comes out. So this stable molecule gets disturbed. So this is exception to this HSAB concept. One more thing you have to remember, that hard acids, soft acids, hard bases, soft bases, that concept is different from strong acid and strong base concept. So strong acid and strong base concept, that is different from this hard and soft acid base concept. So these are the limitations as well as applications of this HSAB concept, which was given by scientist Pearson. So I would like to stop here. Next part we will see later on.